Hello everyone, and welcome back to another remote sensing lecture video. And in this video, I want to continue our discussion on how we can select imagery for a given application. And I want to sort of pick up where we left off last time. And to recap, we had talked about, what specific thing are you trying to identify? Whether you're trying to visualize it in an image or whether you're trying to do something with the pixel values in a classification. And we had said that there's two things you kind of need to consider, right? What is the size of the thing you're trying to map? And that's going to directly relate to the spatial resolution that you need, right? Through this concept of the minimum mapping unit and how that relates to spatial resolution. And then we talked about, what are the features of what you want to identify? And we sort of simplified that down to what are the special characteristics, right? Is there something unique about this thing? Or is there a time of the year when this thing is unique? Does it have does it emit heat? Does it do something special in near infrared? Right? Are there certain things that make it special? And how can we maximize that? How can we maximize those special characteristics in the imagery? Okay. So now what I want to do is I want to take a kind of a step back from that and say, okay, now that we know what we're trying to map, let's talk about where we're trying to map it. And the where we're trying to map it, that's often referred to as the study area or the project area. And I think it's really important to consider that, what is the size and shape of your study area. And sort of an ancillary question is it accessible? Is it easily accessible? Okay. So I want to sort of explain what this question means. What is the size and shape of your study area? And I want to sort of relate that to how that might affect what type of imagery you decide to go with. Right. And let's say that your idea is to map all of the forested areas of, say, the town of Islip, which is a town on Long Island in New York. And you might think, okay, the town of Islip, it's relatively small. So you might think of going to something like Planet, for example, which has a spatial resolution of 3 meters, which is more than sufficient in terms of meeting that minimum mapping unit. And it has a near infrared, which would give you the ability to pick up on near infrared radiation, which is extremely important in measuring vegetation. So it checks those two boxes. And then you look at the size and you say, okay, a Planet image covers, a reasonable amount of area. So everything would work for that. But now let's say that you scaled it out and you said, I want to map every single forested area in the United States that was bigger than 100 acres. Right. Now suddenly you haven't changed what you're trying to map, right? You're still trying to map every forested area greater than 100 acres. But you've changed the size of your project area. Now, because we're talking about the entire United States, right? Planet imagery is probably not going to be viable. Right? That 3 meter spatial resolution would mean that the data volume for the entire United States would be unwieldily large for most people. So now you have to go back to the drawing board and say, okay, I can't use this imagery. It's not scalable to the project area that I'm working on. So then you might look at something like Landsat, which has a 30 meter spatial resolution, which is still good for the minimum mapping unit, right? You're still far smaller than the 100-acre minimum mapping unit. It still has that near infrared wavelength band. So you still have the ability to discern that critical vegetation wavelength, right? But now you have imagery that is much more in line with the size of your project area. So hopefully that makes sense. So let's go ahead and let's sort of put that down in words, right? If you have, say, something, let's just say if you have something that is like, say, 10 km square study area, right? Aerial imagery is probably okay. If you have an entire state, right, you probably want satellite. Right, and this just has to do with the amount of data, right? To get aerial imagery for the entire state would just be an unfathomable, but it would be a prohibitively large data volume. Versus if you use something like Landsat at the state level, right? If you use something like Landsat at the state level, it's going to be a far more manageable data volume. Again, assuming that the spatial resolution meets that minimum mapping unit. So let's kind of flip this question on its head here. This isn't one of the questions that you need to answer, but let's just say what happens when your minimum mapping unit and project area don't mesh. Right. And what I mean by that is, what if your goal was to map every single tree crown in the entire state of New York? Now, right, at face value, just that seems kind of like an absurd objective. But let's just say that for some reason that was your objective, that you were trying to map every single tree crown in the state of New York. Well, you would go to the first two questions, right? What's the smallest thing you're trying to map? Well, I'm trying to map tree crowns, which means I'm going to need something on the scale of centimeters, right? I would need ortho imagery, something that's got like a 30 centimeter spatial resolution to meet that minimum mapping unit of a tree crown. Right. So then you say, okay, well, what's my study area? Well, my study area is the entire state of New York. And like I just said, the entire state of New York, 30 centimeter imagery is going to be an unwieldy data set. So what do? Well, in that case, you have two options. Well, you have three options. One, you get more computing power and devote more time. So yeah, what do you do? So let's say one, all right, get more computing power. /time. Right? Maybe you hire out a supercomputer and you give it a month instead of trying to get this done on your personal computer in a weekend. Right? Maybe you hire out a supercomputer and give it a month. Two, right? You cut back on your study area. Maybe instead of doing the entire state of New York, maybe you do a township or a county. Right? You decrease your study area. Right? So that the spatial resolution of the imagery required for your minimum mapping unit aligns better with the feasible size of your study area. Or three, right? You change your minimum mapping unit, right? Your MMU, or your imagery. I'm going to slide down here just a little bit so that it's not so close to the bottom of the screen. Right. You go back and you think about your question. And you say, well, is it even feasible realistically, given what I have, to be able to map every single tree crown in the state of New York? Should I maybe be looking at rather than every single tree crown? Should I be looking at, patches of forested area? Or can I maybe get away with every single tree crown in something like a worldview 3, which has a slightly larger spatial resolution, right? Can I push the boundary of that minimum mapping unit a little bit to get something that would be more aligned with an entire state? So hopefully that made sense. As always, if something is confusing, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.